for this revision, okay, so just let's recap again what we have learned in week 3 until week 6 lah, okay. So actually I have covered for the circuit analysis, okay, where in this circuit analysis you have learned node analysis, and also you have covered the mesh analysis lah. Okay, so in this node analysis, you have learned how to use this node analysis when you have a circuit only with independent source, and also with the dependent source. When you have the dependent source in your circuit using the node analysis, you need to come up with the constraint equation lah. Okay. And then also for the node voltage, we also have the supernode. Okay, what is supernode? Supernode, you know that when you have two nodes here, let's say you have V1 and V2, and then sharing the same voltage source here. So this is the supernode lah, whether it was independent or we have the dependent source lah. Okay, so whether you have the independent or dependent source which is sharing the same node. Okay, so we have this, we call it as a supernode lah. Okay, and then for the mesh as well the same. So we have the independent analysis, we have also the dependent, and we have also, when dependent, of course you need to come up with the constraint equation lah. And then also we have the super mesh. Super mesh happen when you have two mesh, let's say I1 sharing the same current source. Okay, sharing the same current source with two mesh. All right. So in order to calculate for the super mesh, you need to calculate one equation. Let's say you have two mesh, so means that you need to calculate the super mesh from I1 and I2, and also from the node 0 where you have the super mesh here lah. All right. And then also we covered the circuit theorem, okay, where we have superposition, we have source transformation, and also we have the Thevenin and northern. Okay, and the last one we have covered the maximum power transfer lah. Okay, and where this Thevenin and northern, like I said before, it was related with each other, and the maximum power transfer, it uses the Thevenin equation lah, where Pmax is equal to VTH squared over 4RL, or this RL is actually equal to your RTH lah. Okay, so inshallah we try to do a few exercise or example in this revision. Okay, so we start with node voltage analysis first. Okay, so for this question, obviously lah, node voltage, right? So of course you need to calculate the voltage lah. So find V1 and V2, where in this circle it is already put where is the V1 and where is the V2 lah. First, when using the node analysis, the first thing that you need to do is that the current directions, because you know that from these current directions you need to sum the positive current, which is equal to the negative current, where this positive current is actually entering the node, and the negative current is actually leaving the node. So if you have these directions of current which is entering the node, we call it as a positive current. And then when you have the current leaving the node, so we put it as negative current lah. Okay, so let's say for this example, let's say you want to put all the current is leaving the nodes here. So means that you only have the negative current equal to 0 lah, because you don't have any positive current. Okay, so let's say it was like that lah. Okay, so for this one, for this direction, is already have 3 milliampere, but it was opposite directions, right? This one go this one, and then you have here, so you can just put here as a 3 milliampere lah. And then for these directions of current, you know that you will have V1 over 5K, and then for this direction of current, you have V1 minus V2 over 6K lah. And then you can just put into your equation where you will have negative 3 milli plus with V1 over 5K plus with V1 minus with V2 over 6K equal to 0. So this is your first equation. You need to simplify this equation lah. Maybe you need to times this with 30K, and then you can simplify. Okay, when I simplified, I get 11 V1 minus with 5 V2 equal to 90. So this is actually your equation 1 lah. And then you also have the node V2 here, right? So node V2, let's say you want to do the directions of current also leaving the node. Let's say it's all also leaving the node. Okay, if you follow these directions from the leaving the node here, you will have V2 minus with this V1 over 6 lah. Okay, and then for here you will have V2 over 4K, and this one is going to be 2 lah. Okay, so for this V2 you will have the equations going to be V2 minus with V1 over 6K plus with V2 over 4K plus with 2 milliampere, and then equal to 0. So this is your second equation. You need to simplify this by this, and then you can get your equations going to be V1 minus with 2.5 V2 equal to 12. So this is your second equation. So you need to solve first and second equation, which is this equation with this equation, okay, by you might using the elimination method, or you might using the substitution method lah. Okay, it's up to you. I think for this one you can just use the substitution method, right? Because from this equation 2 you can just put it as V1 equal to 12 plus with 2.5 V2, and then from here you can sub this equation 2 in equation 1 here, so then you can get the value for V2. So when you do that, you can get your V2 is actually equal to negative 1.8667 volts, and then your V1 is actually equal to 7.333 volts lah, right? So yang dekat sini saya nak you faham je. I want you to understand lah, okay, because the question for the circuit can be any circuit lah, okay, so it's important to understand, okay. Alright, so for this example also, the question asks you to find the V1 and V2. Okay, obviously we have a supernode at V1 and V2, okay, where we have the supernode V1 and V2 here. Okay, so for your equation, you need to find equation at node V1 combined with node V2, and the other one is you need to find the equation for the supernode lah. Okay, let's say first we want to find the equation at node V1 and V2, which is the combination of the supernode happen lah, which is V1 and V2. Okay, if you look at here, you know that you have this current directions here. Let's just draw the current direction this way and then this way. Also you have this, okay, just draw that here, that, okay, this direction. So means that all your current here is leaving node V1 and V2 lah. So means that you only have the negative current and then equal to 0 lah. Okay, because you don't have any positive current. So it was 0 lah. Okay. So let's do this equation for these current directions where you know that here is 5. So you will have V1 minus 5 over 1K. And for these directions, you will have V1 over 1K. And for this, you have V2 over 1.5K. And for these current directions, you will have V2 minus with 5 over 2K. Okay, so means that for this, you will have 4 equation lah. Okay. All right, so you just put it into this equation where you have V1 minus with 5 over 1K plus with V1 over 1K plus with V2 over 1.5K plus with V2 minus 5 over 2K and then equal to 0. So this is your first equation. So for this equation, you might simplify. Right, so I think that 2 example is enough for node analysis lah. So now we move on to mesh current analysis. Okay, so for this example, the question asks you, you need to find I1, I2, the value for V1, V2, and as well for the current at IR2 here lah. Okay, so from this circuit, you know that you have 2 mesh, right? You have mesh I1 and I2. So you need to find the mesh current from I1 and I2. And also you need to find the equation for I1 first. Okay, let's say we find the equation for I1. Okay,
I1.
I1. Okay, lagi. Follow the current directions here, right? And then plus with, okay, katalah sini plus with apa ni? Negative 1 plus with this one 1.1 minus with 1K I2 equal to 0. So this is gonna be your equation 1. When you do the simplification, you will get 0.1 plus with 2.2K I1 minus with 1K I2, which is equal to 0. This is your equation 1. And then for your mesh I2, what you got is from here lah. From here, you will have -2. Just start from here. -2 plus with your total of your resistor, where you know that the total of resistor is 3K I2 minus with 1K I1, and then minus with 1.1 equal to 0. And then when you simplify this equation, you will have -3.1, where you just sum this up, plus with just start with -1K I1 plus with 3K I2. So this is going to be your equation 2. So you just need to solve equation 1 and 2. You might using the substitution method or elimination method lah. Okay, when you solve for this equation, you can get I1 is equal to 0.5 milliampere, and then I2 is equal to 1.2 milliampere lah. Okay. So you already have the mesh current for I1 and I2. So now let's find the IR1 here. Okay, IR2. So, okay, IR2 is these directions, right? So you can find IR2 is actually equal to V1 minus V2, V1 minus with V2 minus with minus 1.1, where it will be plus with 1.1 over 1K. So this I, you know, the Ohm's law, I equal to V over R, right? So just V1 minus with minus 1.1, which is plus 1.1, minus with V2, and then over 1K. So from here, you can find that your IR2 is actually equal to 0.7 milliampere lah. Okay. And then after that, you can find the value for V1. So this is your for this one you don't have any value for V1 and V2, right? So for IR2, it's easy if you can use the current directions. Okay, let's say your IR2 is here, and here obviously this is I1, and here obviously this is I2 lah. So you know that your directions of current for IR2 is here. So you know that from here you can create an equation where I2 is equal to I1 plus with IR2, where you know that your IR2 is equal to I2 minus with I1 lah. So I2 minus with I1, so 1.2 milli minus with 0.5, so you can get IR2 is also equal to 0.7 milliampere. But if you want to use this equation also can, but you need to find the value for V1 and V2 first. Okay, so I think that's easy if you use this equation lah in order to find the IR2. Okay, so for V1, okay, so you know that V1 is here, right? So the current directions for V1 is equal to I2 here. So your I2 is equal to, you know that this is the I2, you know that the directions is here. So I2 is 0, here 0 minus with -2, where you can have +2 minus with V1 over with 500. So your means that your I2 is actually equal to 2 minus with V1 over 500. So you can just substitute this I2 with 1.2 milli times these two, and then you can get the V1, where your V1 is equal to 1.4 volts lah. All right, and for your I2, this is your I2, where the current directions for here is this one lah, is also I2 current lah. So this is I2. Okay, so you know that V2 is actually equal to I2 times with R4 lah. Okay, so V2 is equal to I2 times with 1.5K. So when you calculate, you can get your V2 is equal to 1.8 volts. All right. So you already find all the values here lah. Okay. So we move on to another mesh analysis where here actually you have a super mesh lah. You have this super mesh because how many mesh that you have for this circuit?
3.
Okay, 3, right? You have 3 mesh where you have this is, let's say this is I1, this is I2, and this is I3. So your super mesh, super mesh is in between what mesh current? Your super mesh happen where? Kat mana?
I2, I3.
Okay, I2 and I3, right? So, how many equation that you need to come out for these 3 mesh? Berapa equation kena dapat untuk ada 3 mesh ni?
2.
3 equation lah, 3 mesh, 3 equation. Kalau ada 2 mesh, 2 equation.
Tapi dia super mesh, bukan sekali ya, doktor?
Memang sekali, but you need to calculate the node 0 here. The node 0 equation. The node 0 equation here. So, node 0, sini kita panggil node 0 lah where the super mesh is happen. Okay, here. So means that you have 3 mesh. You have 3 mesh where you have I1, I2, and I3. So means that you need to get 3 equation. Okay, so these 3 equation coming from where? Okay, the first one is coming from this mesh I1. Okay, this is the first equation. The second equation is coming from super mesh I1, I2, and I3. And the third one is the equation at node 0 here, where your super mesh is happening here lah. So another equation is from node 0. So you have these 3 equations. Okay. So let's do the first equation where we have the mesh I1. Okay. The equation from the mesh I1. Okay, apa equation dia? Okay, let's start with -2 plus with 5k I1 minus with 3k I2 equal to 0. Okay, betul tak equation saya? Okay, so this is your first equation. And then the second equation is actually super mesh I2 and I3. So this is the super mesh, means that you have the another loop here. Okay, this is your super mesh lah. Okay, so for your super mesh, let's start from here where you can combine these 3 plus with 2, where you have 5k I2 plus with 4k I3 minus with here lah, minus with 3k I1 equal to 0. Okay, equal to 0. So this is your second equation. Okay, so and then the third one is equation at node 0. Okay, where your node 0 is here. Okay, just let's draw the node again. Okay, let's see, this is your node 0 where you have this current directions where you have 0.4i, and then you also have these current directions where coming from this I3, just put I3 here, and also you have this from I2. Okay, so you will have this, and then from here, just equate the positive current equal to negative current again lah. Okay, so just use this KCL. All right. So where you can have what you have here, 0.5i. This is the positive current, like this is positive current, and then negative. So you will have 0.4i plus with I3 equal to I2. So now you don't know what is your I here. So where is your I? Your I is here, right? So from this, you need to find what is your I. Okay, so you have your I is this directions, and then this is your I1, and then this is your I2. All right, so obviously your I is equal to berapa? I from here. Okay, from here you know that your I1 is equal to I plus with I2. So just rearrange this equation. So I1 is equal to I1 minus with I2. Okay, so you need to sub this equation into this I. So 0.5 times with I1 minus with I2 plus with I3 equal to I2. So then when you do the arrangement, you can have 0.4 I1 minus with 1.4 I2 plus with I3 equal to 0. So this is your third equation. So you have all the 1, 2, and 3 equation here. So you need to solve equation 1, 2, and 3. You might use the Cramer rules. Or if you think that the Cramer rules is a bit complicated because you need to find the determinant and so on, so you can use the substitution method even you have the 3 equation. Okay, so when you solve this equation, you can get your I1 is equal to 0.5408 milliampere. Your I2 is equal to 0.2347 milliampere, and then your I3 is equal to 0.1122 milliampere. So this is all the value for your I1, I2, and I3, but the question asks you to find the V node here. So what is the equation for the V node, guys? I3. So I3 times with 3K, yeah, because we want to calculate the V here, not here. But if you have V, let's say V4 here, so you need to use this resistor lah, because the V here, V node here, so you need to use this R5 lah. Okay, so V node is equal to I3 times with 3K. So when you calculate, you can get this value lah, 0.3367 volts. All right. Okay, dapat? I think that we move on with Thevenin and Northern lah. Okay. So again, Thevenin, you need to find VTH and RTH. Okay, where you have this Thevenin voltage, which is series with RTH. Okay, so this is your VTH and this is your RTH at terminal A and B. And then for Northern, you need to find IN and RN, where you have the current source, which is parallel with Rn lah. So this is Rn, this is In, and this is your terminal A and B lah. And then this can be just vice versa, or you can just use the source transformation lah in order. If you find the value from the Thevenin, you can find the Northern, and from the Northern also you can find the Thevenin. Okay. So it's just that lah. So for the RTH, there is a 3 method lah that you can use. So for the first method, when you have all independent source, and these two when you have the dependent source lah. Okay, so we're gonna look at that in our example lah. Okay. Okay, so first question is to find the Thevenin equivalent. So obviously, Thevenin equivalent, of course, you need to find VTH and RTH. Okay. So, let's say when you analyze the circuit, in order to find the RTH, what method that you need to use, because you have 3 methods, right? You have method 1, you have method 2, and you have method 3. So what method that you can use in calculating your Thevenin resistance, guys, from this circuit? Method apa yang you all boleh guna kalau you ada circuit macam ni? So what method that you can use, whether method 1, method 2 or method 3?
Method 1.
Why method 1?
Independent source.
Bukan, okay, betul. Independent source, because we have all independent source, right? So obviously for method 2 and 3, it's if you have the dependent source lah, so you can just pangkah dah method 2 and 3, just straight away use method 1 where you can just turn off all the independent source. Alright, so means that in order to calculate your RTH, you can just turn off these two. Okay, let's say for RTH, when you redraw again the circuit, you will have this circuit lah. Okay, this is terminal A and B, where you have, this is 9.1K and this is going to be 82.K, and here going to be 7.5K. So you can start calculating from this side lah, okay, where you know that 9.1 dengan 8.2 is series, right? So you know that your RTH is equal to 8.2K plus with 9.1K, and then parallel with 7.5K. So when you calculate, you will have the value is 5.2319 kilo ohm. So this is the value for your RTH lah. Okay, so now when you want to calculate for your VTH, all right, so you know that your VTH is actually here lah, because this one is equal to this VOC. Okay, so this is your VOC as well lah. So this is your VTH. So this is your VTH lah, this direction. So in order to calculate for VTH, you might use the node voltage, or you might use the source transformation ke, mesh ke, what method that you want to use, and it was easy for you lah to do the calculation lah. But from here, I use the source transformation method lah, and then I use the KVL, okay, where you can transform this part of circuit into a voltage source, where you can just, you want to calculate for the V, where you have 1 milli times with 9.1K here. So here you will have your voltage is equal to 9.1 volts lah. And then when you redraw again your circuit, you will have your voltage here, which is 9.1 volts, and then this is your resistor, which is 9.1K, and then you have 8.2K here, and then you have 7.5K, and then you have 12 volts here, okay, at terminal A and B. So you can use the KVL here, where you know the KVL is actually the summation of voltage equal to 0. Okay, so you can just, first you can find the I here, sum of the voltage here, because you want to find the VTH here, right? So you can sum all the voltage here in order to find the value of I, and then from here you can find the value for the VTH lah, okay? So you can just sum all the voltage here, where you can have, starting from this, where you have the current directions, right? Where you have negative 9.1 plus with, just add all the resistor here. Well, when you add 9.1, 5.2K and 7.5K, you find that your resistance is going to be equal to 24.8 kilo, which is I times with this I, and then plus with 12 volt, plus with 12, and then equal to 0. So now you can easily find the value for I lah. And then when you get the value for I here, is actually equal to 0.116935 milliampere. Okay, so now you already have the value for your I here. So now it's easy for you to calculate for your So V is equal to I times I, your current times with your resistor lah. Okay, so what is your I here, guys? VTH here. Okay, but you know that your VTH here, your I here have this 12, right? So means that your I here is this value, but your VTH here is actually VTH minus with this 12 lah. Okay, so means that VTH minus with 12 equal with I, which is 0.116935 milli, times with your resistor, which is 7.5K. So when you calculate for this VTH, okay, just rearrange the equation. So you know that you will get the value is equal to 11.123 volts. All right, so this is your VTH. So now you have complete equivalent circuit lah, where you find the RTH and also the VTH. So now you can just draw the equivalent circuit, okay, where you have this is your VTH and this is your RTH, where your RTH is equal to 5.2319K, and then here your VTH is 11.123 volts. All right, so you've done with your Thevenin equivalent circuit lah. Okay, to the node where if you're using the node, you kena carilah V1 kat sini and the VTH here lah. So means that you need to have two equation where you kena cari kat sini, where here kalau nak buat equation from here you have negative 1 milli plus with V1 over 9.1K plus with V1 minus VTH equal over 4.28K equal to 0. So this is your first equation. And then to the second equation, which is this direction, let's say yang ni pun masuk dan yang ni keluar. Masuk and then keluar. So means that for this equation, saya tulis kat sini lah, for that equation you will have V1 minus VTH over 8.2K equal to sini VTH minus V12, VTH minus V12 over 7.5. So this is your second equations lah. So you can solve for first and second equation and then you can get your VTH lah. Yang ni pun boleh jugalah, sama juga. If you try to do using the node pun you will get the same equation, the same answer lah. Where your VTH is equal to 11.1230 lah. Okay, so this is actually up to you lah. Kalau you rasa alah tak reti lah nak buat source transformation ni, you boleh buat je guna node. Okay, is Thevenin as well. So you need to find VTH and RTH lah. Okay, so for this one, you know that your circuit have the dependent source here, right? So means that you have 1, 2, 3 methods. So you cannot use this first method. So in order to calculate RTH, you either use method 2 or you can use method 3 lah. So these two methods going to give you the value for RTH lah. But you cannot use the first method where you just only turn off this and then you can calculate. You cannot do that lah because you have this dependent source, right? So from this, how to calculate the value for, let's say first we calculate for VTH, right? So obviously here is your VTH lah. And there is no, if you have, we want to calculate VTH here, so you cannot use this R5 because there is no connection here because this is open circuit, right? So there is no connection for R5 or there is no current through this R5 lah. So your circuit gonna be this circuit only lah, okay? So what method that you want to use in order to calculate for VTH? Which one is easy? I think it was the node voltage lah, because here it's already put you V1 here lah, so you can just put V1 here, and here is going to be your VTH. Okay, so let's get the equation for the node voltage for V1 and VTH lah. Alright, so for V1, what equation you have? Let's say you put all the leaving current here, right? So means right here you will have V1 minus V3 over 4, and for this direction you will have V1 over 6, and for this one V1 minus VTH over 5 lah. Okay, so all is leaving the node, so means that you will have the negative current equal to 0 lah. Okay, and then just now put into this equation. Okay, just sum everything lah. Okay. And then equal to 0. So for this one, you need to simplify. You might times this with 60, and then you can find that your equation is going to be equal to 37 V1 minus with 12 VTH equal to 45. So this is going to be your first equation at V node lah. And now let's get the equation at node VTH. Let's say this is your current directions and this is the current direction. So means that one is entering the node and one is leaving the node. Alright. So you will have your equation is V1 minus with VTH over 5 equal with VTH minus with 2V1 over 3. So this is going to be your equation 2. So you need to simplify this first. So you can simplify this, I think, by times this with 15. And then you will have this equation as 13 V1 minus with 8 VTH equal to 0 lah. So this is your second equation. So I think that for this one, it's easy if you just use the substitution method, where you can just directly find the value for your VTH, where you know that from, let's say, just simplify from here, you will get here V1 equal to 8 VTH over 13. So you can just sub this equation into this. Okay, just sub here. So directly you can get the value for VTH lah. So where you can find your VTH is equal to 4.1786 volts. Alright, so means that you don't have to find the value for V1 pole. You can just directly get the value for your VTH lah by using the substitution method here. Okay, so then you can get the value here. And now you need to find the value for RTH. Let's say you cannot use the first method, right? Because you have this dependent source. So let's say you using the second method. What is the second method? If you are using the second method for your RTH, right? So just right here lah. Kita buat border sini. So sini kita nak cari RTH. Okay. So to find the RTH, if you're using the second method, so means that you add the test voltage or test current, which is V node or I node, both is equal to 1. And then you can turn off the independent source lah. Okay. You can turn off the independent source. Alright. So you can just do these two things lah. Okay, if you are using the second method. Okay, if we are using the second method, we can just draw the circuit again lah, where you need to turn off this and then just add one. Let's say we add the current source here, which is I node lah. Okay, so let's draw the circuit again, where you have this. Okay, you will have this circuit, where you add the, okay, here is positive, negative, here you add the I node, the test voltage, which is equal to 0. So this is your V node here lah. Okay, so let's say here is 2v1, this is 7, this is 3, 5, 4, and 6, and this is your V1. So here it's easy if you first find the voltage here, which is V1. Let's say this is V1 and this is V2 here, and then you can calculate the value for V naught. All right, because you know that V naught here is actually equal to, if you follow this current direction, V naught here is by using, you know that the current here is 1, so means that V naught minus with V2. So for V naught, we can have V naught minus with V2 equal to 1 lah. Okay. 1 times with this 7. 1 times with 1 times with 7. So you can get the value for V naught. Okay. So let's come up with equation for V1 here. Okay. Saya nak bagi muat juga, boleh tak? V1, the equation is, let's all the current is leaving the node lah. Okay, let's like this lah, the current. Where here you will have V1 over 4 plus with V1 over 6 plus with V1 minus V2 over 5 equal to 0. So this is your first equation. And then at node 0, at node V2 here, you will have V1 minus V2 over 5 plus with V2 minus with 2 V1 over 3, and then plus with the current I node here, which is entering, oh silap, this one gonna be plus with 1 and then equal to 0, equal to this one, and entering kan, this one gonna entering, this is entering, which is equal to 1, so means that V1 minus with V2 over 5 plus with 1 equal with V2 minus with 2 V1 over 3. So this is your second equation lah. When you do the calculation, you get the important value that we want to get is this V2 lah, this V2, because we need to substitute this V2 value here in order to get the V naught here lah. So if you calculate, you can get your V2 is actually equal to 3.9642 volts. All right, so you can substitute this value here, V naught minus with 3.9642 equal to 7, and then you calculate to get the V naught. All right, so your V naught is actually equal to, when you calculate, you get your V naught is actually equal to 10.9642 volts. And then you know that your RTH here, from this one, your RTH is equal to V naught over I naught, right? So where's your V naught is this value lah, 10.9642 over 1. So obviously your RTH is equal to 10.9642 ohm. Okay, so now you already have the value for your VTH here, and then you also have the RTH here. So you can just draw again the circuit, the equivalent circuit lah, where you have this is RTH and this is your VTH lah. Okay, so just put the value 10.1642 ohm, and then here you will have 4.1786 volts. All right, so now you've done with the Thevenin equivalent circuit lah. Okay, V naught tu kan. Okay, let's say untuk kira RTH tu kan. Okay, so disebabkan oleh, because of we have the dependent source here, so we can use, I use the method tu lah. Okay, where we put here the test current, where this I naught is equal to 1, and then here is your V naught lah. So this is here your V naught. Okay, when you draw again the circuit, you kena turn off lah. Okay, so bila you draw again the circuit, you akan dapat Okay, katalah this is your circuit lah. This is 4, 6, 5, 3. This is 2V1, where this is your V1 lah. And then this is your 7, and this is I naught equal to 1. Okay, so this is your V naught lah. Okay, so you know that from this circuit, you can find the RTH, where RTH is equal to V naught over I naught. Either you put here the test voltage, which is V naught equal to 1 or I naught equal to 1. But for this case, I just put the I naught equal to 1 lah. So you need to find the value for V naught and then over 1. So then you can get the voltage. So from this equation, how to find the V naught here, right? So you know that V naught, you cannot directly get here the V naught because we have the resistor here, right? So the potential difference here. So let's say here I put this V2, right? So you can find the V naught here by let's say the current directions here, because the current directions here is actually equal to I naught equal to 1 lah. Okay, boleh follow tak?
Boleh.
So equal to 1. So V naught here means that the difference here lah, V naught minus with V2, right? V naught minus with V2, which is equal to I times with lah, the current, IR, current 1 times with V7. So you can find the value for V naught lah. So where V naught is equal to 7 minus with V2. So now you can get the value for V naught lah. Where the V naught, as I calculate, then I get this value lah. Okay. When you have the V naught, so you can just put the V naught is 10.9642 tadi kita kira. So then you can just put the value here lah, 10.9642 over 1. So you can find that your RTH is equal to 10.9642 lah. Okay, ohm. Alright.
V1 minus VTH over 6 dengan V1 minus VTH over 5 tu.
Mana?
Kalau tengok dekat V1 tu kan, ada yang tulis plus tu.
Oh silap, yang ni 5. Sorry. V1 minus VTH over 5. Silap. 5 kat sini bukan 6. Bagus, you notice lah, maksudnya faham kan? Dia sepatutnya kat sini lah. V1 minus VTH over 5, bukan 6, saya silap tulis. Okay? Boleh tak?
Lagi satu random nak tanya.
Okay.
Kalau macam yang sebelum ni kan, yang maksud untuk parallel tu, kita kena tambah.
Maksud untuk parallel, maksud you untuk resistor ke parallel resistor? Okay, untuk parallel resistor. Okay, parallel resistor macam ni. Ni kita panggil parallel resistor lah. Kalau ni parallel. Katalah R1. Betul ke? Betul ke yang saya buat ni? Ke you nak tanya soalan lain? Hello? Betul
Macam yang Madam tunjuk dekat slide yang Thevenin equation.
Yang ni?
Yang satu, yang tu, yang ni. Yang RTH 8.2K plus
ni 9 ni.
Apa maksud parallel dia tu?
Maksudnya ni bukan parallel, dia series. 8.2 dengan 9.1 ni series dua ni. So that's why kita tambah. Bila parallel, kita kena buat parallel lah 7.5. So kalau parallel maksudnya, you ingat tak macam mana nak kira parallel? Okay, contoh kalau macam saya ni kan R1, R2, kalau untuk kira parallel maksudnya R1 darab dengan R2 bahagi dengan R1 tambah R2. Betul kan? Orang ingat tak ni? Daripada sini. So ni maksudnya R1 parallel, dia punya simbol selalu parallel, kita buat macam ni lah, parallel dengan R2. Ini maksudnya parallel lah. Betul? Faham tak?
Faham.
So maksudnya macam tu lah, ni parallel. So maksudnya kalau dia macam ni dan macam ni pun parallel jugalah. Yang ni dengan yang ni. So R1, R2, yang ni pun connection dia parallel lah. Yang ni pun parallel, yang ni pun parallel, sama je. Kalau series yang jenis macam ni, ni kita panggil series lah. So series ni kita boleh tambah je. Tapi kalau series dia punya voltage lain. So ni akan jadi VR1, yang ni akan jadi VR2. Kalau parallel, sama je voltage dia. So VR1 ni pun sama juga dengan voltage VR2. Macam tu lah, tu dari segi voltage lah. Okay? Boleh dapat tak?
Maksudnya pengiraan dia untuk parallel, yang simbol parallel tu kita abaikan, maksudnya kira yang depan je lah yang tambah tu.
Abaikan maksudnya macam mana?
Kalau kita tengok slide tadi kan,
Slide ni?
yang awal tadi, yang tu.
Ni?
Maksudnya pengiraan dia macam mana?
Yang ni kena kira lah. Okay, kalau from here, maksudnya macam ni you kena kira. 8.2K tambah 9.1K ni dapat berapa? 8.2 tambah 9.1K ni dapat berapa guys? You all dapat berapa? Saya tak kira pula berapa dapat. Kira dapat apa? 8.2 tambah dengan 9.1K dapat 17.3K, betul tak?
Betul.
Okay, dapat 17.3K. So maksudnya 17.3K ni lah akan parallel dengan 7.5 ni. Okay, so maksudnya bila parallel, maksudnya kalau kiraan penuh dia 17.3K darab dengan 7.5K bahagi dengan 17, nanti masuk sini 17.3K tambah dengan 7.5K. So dapatlah value dia sama macam ni lah. Betul tak? Cuba you kira. Kan? Sama kan? 17.3 shift K, shift K kalkulator saya lah, darab dengan 7.5K tambah bahagi dengan yang tu. Kan you dapat value sama ni kan? So macam tu lah kira dia. Parallel tu maksudnya kena kira darab yang ni bahagi dengan jumlah tambah yang ni dengan yang ni lah.